Hello. In this tutorial I'm gonna show a way to bring some variation and movement into an LFO modulation source, and will then build a patch with a voice that will be modulated by this LFO. The end result will sound something like this. So let's get going. To start, I'll add a 4FO module by Bogaudio, which is an LFO that has 4 outputs that are offset relative to each other. I'll use an oscilloscope by Count Modula to visualize this. Connect the outputs to the scope. Set the 4FO module into slow mode. Change its frequency to a quarter of the default value. And switch the waveform to a triangle. Now if I turn down the time on the oscilloscope, you see that those 4 outputs are using the same LFO pattern, but they are in a different position of that pattern. Now this can provide a great modulation source for different parameters in your patch, but since the outputs are all based on that same LFO and are always moving in the same way relative to each other, if you listen to such a patch for a while, you might start to notice that pattern in there. So how can we mix this up a bit? Well, there are these 4 phase knobs on the 4FO, one for each of the outputs. And if you look at the red line in the oscilloscope, you'll notice that when I start turning this knob, the red line starts to move to a new position. When I stop turning the knob, the LFO pattern continues in that new position. And if I turn the knob again, the red line moves to a new position again. When I stop turning it, the LFO pattern re-emerges in that new position. There is also a phase CV input for each of these knobs, which specifies how much of the value assigned to the knob should be applied to the output. So if I start providing a variant voltage on this CV input, I can start moving the output around. And to get the largest range of motion available there, I'll turn this knob to its maximum value. Now I'll add a Branes module by Geodesics, which is a module that can provide random voltages on each of its outputs. I'll use a voltmeter and connect it to some of those outputs, and you see that they are generating constantly changing values. Now if I were to use this as input for the 4FO, it would also turn the outputs completely random. But the Branes module has a trigger input, which would turn it into a sample and hold. So I'll add an LFO. I'll use the LFO by Bogaudio. Set it to 4 Hz. Switch it to a square wave and use that as trigger input for the Branes. And now the output of Branes changes every time a trigger is received. Now it's changing a bit too fast. I could reduce the frequency of the LFO, but I want to use that 4 Hz later on. So instead I'm gonna add a chances module by Count Modula. The chances module is a trigger randomizer. You provide it a trigger on the input, and it will send that trigger at random to either the A or the B output. And how often it goes to each of these outputs is defined by this knob. If I set it to 25%, that will mean that about 1 in 4 of the incoming triggers goes to the B output. So now you see that the voltmeter changes every time the chances module sends the trigger input to the B output. Now it's still changing a bit too fast, so I'm gonna use another trick that Branes provides. If I right click, you can set the high Brane, so the top circle, into young mode. And now instead of changing all of its outputs each time a trigger is received, it will choose one of the connected outputs at random and change the value of that output and keep the others the same. So you see over here, every time a trigger is received, the voltmeter shows that only one of the outputs changes value. And you can also see that over here in the oscilloscope that the red line now jumps a lot less frequent. But the changes in the red output are still jumps. They are abrupt changes from one value to the other, which is usually not something you want from a modulation source. You want changes to happen gradually. In order to achieve that, I'm gonna add a slew module by Bogaudio. connect the Branes output to its input and the output of the slew module to the 4FO. What the slew module does is, when it detects a change of value on the input, it will make that change happen slowly on the output. It will move slowly from the old value to the new value. And you specify how quickly that change happens with the rise and the fall knobs. Gonna set both to 5 seconds. And I'm also gonna put the slew module in slow mode, which slows it down even more. So now every time a change happens on the Branes output, the slew module will make that change happen gradually in the 4FO, and you will no longer see those big jumps in the red output. It will slowly move from one to the other. And that way we have now changed the red LFO into a more variable output. Now we'll have to do the same thing to the 3 other outputs of the 4FO. Luckily the slew module is polyphonic, which means you can feed it multiple input signals and it will perform its operation on all of those inputs and provide multiple outputs. I'll add in a MergeSplit4 by Grande, connect 4 of the Branes outputs to it, connect the merge signal with the input of the slew module. Now you see that there are 4 signals going in, and on the output side those 4 signals are slowly moving from one value to the other. I'll connect that to the split side of the merge split and use that as input for the 4FO. And if I now open up all of the phase knobs, we now have 4 signals coming out of the 4FO based on the same internal LFO, but instead of being completely in sync with each other, they have some variation applied to them. And we can start using this as modulation source for a patch. And it will not sound as predictable anymore. Now for the patch that I have in mind, I would like to have more than 4 modulation signals. Luckily, the 4FO has a bigger sibling, the 8FO. This module works exactly the same as a 4FO, but it has 8 outputs. So let me quickly change this module with the same settings as I used for the 4FO. Switch it to a triangle. I'll have to open up 8 of the phase knobs here. And now I'm gonna need 8 inputs to vary the outputs of the 8FO. Now the Branes module has a second brain, the lower brain, so let's start using that. I'll add a Merge8 and a Split8 module by Grande, which will replace the MergeSplit4. I'll take 4 of the top outputs, combine that with 4 of the bottom outputs. We'll have to also use the same trigger on the lower brain and set it to young brain mode. And now I can send that merge signal into the slew module. Gonna remove the 4FO and I'll also remove the voltmeter and oscilloscope. The output of the slew module goes to the Split8. And now we can use the separate outputs as input for the 8FO. And now I have my 8 modulation sources that I can use for my patch. The nodes in this patch will be generated by the ProbKey module by Impromptu. This module expects a gate input, and I'll use the LFO for that. And each time a gate is received on the input, it will play a new note. And over here on the keyboard you specify which notes it can choose from. I'll set this to a C minor pentatonic scale, so that's a C, E flat, F, G, B flat, and I'll add an FM-OP module to start playing those notes. I'll also add a MixMasterJr and its AuxSpander. Set the level of the first channel to -10, connect the output of the mixer to the audio output. And now I can connect the CV output of the ProbKey module to the volt per octave input of the FM-OP, and the FM-OP to the first channel of the mixer. Now to make it sound a bit more interesting, I'm also gonna add a reverb, the Plateau module by Valley. And I'm gonna use that as a send effect, so I'll connect the input of Plateau to the output of the aux-A, and then the output of Plateau back to the input of aux-A. A send effect should play nothing of the original incoming signal and everything of the reverb effects. I'll add in some modulation, close down the highs and the lows a little bit, and now we can add some reverb to that first channel. Now right now the ProbKey module is playing random notes every time a gate is received, but I want it to start generating a slowly evolving sequence. The length of that sequence you can set over here in the length knob. I'm going to use 60 notes in that sequence, and using the lock knob you specify how many of the incoming gate signals should play a note that's already in a sequence and how many should play a new random note. So if I set this to around 75%, then about 1 in 4 of the incoming gates will play a new random note, and the other 3 will play the note that's already present in the sequence. Using the density knob, you can also specify that instead of playing a note every time a gate is received, it should sometimes not play a note and just keep playing the note that's already playing. So when I set that to 75%, about 1 in 4 of the incoming gates will not play a note. Now right now the ProbKey module is playing all its notes within 1 octave, but you can also change that over here in the edit octave range. If you click on that, you see that it's all playing in that center octave. But if I open up this side and this side a little bit, there will also be an occasional high and low note in there. Now to start adding some modulation, I'm gonna open up the feedback of the FM-OP so that the module starts feedbacking on itself. And that is something that we can modulate using the feedback CV input. So I'll connect that to the Atenuverter. And now that feedback will move in and out. But the FM-OP module expects a 0 to 10 volts signal to move from no feedback to the maximum configured value over here. And the Atenuverter currently is sending out -5 volts to +5 volts. But we can modify this. Over here, the offset knob on the Atenuverter, if I set that to 5 volts, then the output will become 0 to 10 volts. So we have the full range of the FM-OP available again. Now I'm gonna add in a second FM-OP module to supply some additional modulation. Gonna use the same volt per octave values here, but set it to a frequency ratio of 2, which means it plays 1 octave above. And I'm gonna use that as frequency modulation on the first FM-OP. I'll open up the depth a bit, and you'll hear that frequency modulation come in. Now to make it sound a little bit more interesting, I'm also gonna send a gate to that second FM-OP. I'll use the gate output of the ProbKey, which is triggered every time the ProbKey plays a note. And this gate will now drive the internal envelope, which you can configure over here with these ADSR knobs. I'll increase the release a bit. And then I'll say that this internal envelope should be applied to the volume level of this module. So I'll enable the envelope over here. And now we can modulate the frequency modulation on this first FM-OP, again with the Atenuverter. So now that effect will also move in and out. The second FM-OP also has a feedback setting. So I'll also open up that one. And use another output of the LFO for it. Now I'm gonna add in a filter in this patch. I'll use the LVCF by Bogaudio. And instead of going directly to the mixer, I'll send the FM-OP first into the filter and then onto the mixer. I'll open up that filter a bit. And now we can also modulate this filter. Again with the LFO. If I open up this CV, let's say to around 15%, then this filter will start to move up and down. And this will cause more or less of the high frequencies to be sent to the mixer. Now another interesting item to modulate is the octave in which the ProbKey is generating its notes. If I turn this offset knob over here and you watch the LEDs over here, you'll see that when I turn it to the left, they are also moving to the lower octaves. And when I turn it to the right, they'll move to the higher octaves. And there's also an offset input. But this input expects a negative value to go to the lower octaves and a positive value to go to the higher octaves. And I just put the LFO into a purely positive setting. But we can of course change this. If I add in a dual Atenuverter by Befaco, and I take one of the outputs of the LFO, connect that to the dual Atenuverter and the output to the offset, I can now specify how much of that incoming value should be used, and I can give an offset to it. So if I specify that it should use 70% of the value, or let's say 60%, and that it should be reduced by 3.5 volts. Now the output over here will move from minus 3.5 volts to plus 2.5 volts. So this value will be slightly skewed towards the lower octaves. And you also see that over here, that the octave is moving from the left to the right, as this value slowly moves from minus to positive value. So now the sequence that is generated by the ProbKey will slowly start incorporating lower values and higher values depending on what is coming in over here. And we have a second section over here of the dual Atenuverter, which we could use for the panning input of our voice. So I'll take another LFO output, connect the output to the pan input, and the panning also expects negative and positive values. Negatives to move to the left and positive to move to the right. So I'm gonna say that it has to use 50% of the incoming signal. Set the offset to minus 2.5 volts. And now it will generate a value between minus 2.5 volts and plus 2.5 volts. And you also see that over here, that the yellow line around the panning knob moves from the left to the right, back to the left. Now to make this voice a little bit more interesting, I'm gonna add in a delay, the Chronoblob 2. I'll use the LFO again as sync source. I'll reduce the feedback, which reduces the number of delays, but increase the dry-wet ratio so that the delays are a bit louder. And I'll send the signal into the right side of that delay, and the delay back into the mixer. And I'll put the delay into ping pong mode so that the delay goes right, left, left. And to make the rhythm a bit more interesting, I'm not gonna let it run at the exact same rate as the LFO, but I'm gonna put it in the 1.5 ratio. so that you have a bit of an offbeat in those delays. And now we can also add some modulation to this delay. An interesting thing to modulate on this module are the left and the right delay times. While the main delay knob specifies the overall delay time, the left and the right delay times can be made to slightly deviate from this. We connect the left and the right CV inputs to two Atenuverter outputs, and then we open up the CV knobs for them, let's say to around -10 and +10%. Now the left and the right delay will be slightly out of sync with the main delay, based on the incoming modulation signal. And now we have a voice that is being modulated by the 8 outputs of the Atenuverter. You can of course add additional modules to this patch to further manipulate the sound and use each of the outputs of the Atenuverter to modulate multiple parameters. As is usually the case, the possibilities are endless. Thank you for watching and happy patching.